Welcome, friends. It's another Monday, but more importantly, this is another episode of the On.NET Live show, where our mission is to empower you, the .NET community, to achieve more. I'm your host, Scott Addy. Co-hosts joining me today are Luis Quintanilla and Cassie Breviu. We're changing things up a little bit today in the hosting rotation. I'd like to give a huge shout out to Cassie for joining today and helping out with the show. I'd also like to welcome today's guest, Mauro Bennici. Mauro, could you please briefly introduce yourself to the audience?
Yeah, sure. Welcome, thank you, Scott. I'm Mauro Bennici from Italy, and I'm a .NET developer that in the last 10 years also I moved to artificial intelligence field. And today we'll show you how to combine the .NET, Azure, and also ONNX Runtime to continue to study the machine learning, but continue to use Azure and C#. Yes.
Thanks, Mauro. As I mentioned, we're super appreciative of your time today. I know the audience is excited to hear from you. But with that, before we get to you, let's transition into our related bits segment for today.
All right. So for today's related bit segment, we have this document. It's inside of the Azure Machine Learning documentation site. And the name of the article here is Make Predictions with AutoML ONNX, an AutoML ONNX model in .NET. Right. So it's very related to the topic we'll be talking about today. One of the options that you get when you're training in Azure Machine Learning with AutoML, which is automated machine learning, is the option to export your model into ONNX format. Now, I'm not going to get into sort of ONNX. I'm sure Mara will talk to us about that later today. But in general, it's just a way to represent these machine learning models in sort of a standard way, and you can sort of share models across frameworks. And in this case, we're doing that with the components in AutoML inside of Azure Machine Learning, converting it to ONNX, and then using that model we convert it to ONNX and importing inside of our .NET application. Right? And the general way that you go about doing that is you can use the ONNX Runtime package here. This is a NuGet package. And in this case, we're actually going to be using ML.NET to perform some of this inference, but that's just, if you want to use ML.NET, you can use the ONNX Runtime without ML.NET, right? So just whatever your preference is there. Once we install the packages that we're going to need here, we just reference the ONNX model. In this case, we're just have a single file called automlmodel.onnx, and that's the actual artifact containing our machine learning model. From there, we imagine in this particular case that we have a model that's trying to predict taxi fare, right? So this is sort of what the data looks like. And what we do now is we go ahead and create inputs and outputs for our model. Now, you might ask yourself, how do I go about understanding what the inputs and outputs are of a model? Well, a way that you could do that is with this really neat tool called Netron. And it's a little bit hard to see here. But if I zoom in just a little bit more here, you can see that this will show you information and metadata about the model. In this case, you can see that the inputs here are, these columns here: vendor ID, rate code, passenger count, which again, you'll notice they'll sort of map to these columns in our data set. And you're going to see here that our output is this variable called variable out1. And that's going to be basically the fare amount, or the thing that we're trying to predict here. Right. And you see that you also get information about the type that each of the columns represents. Right. So this is what you can use to then define classes or POCOs for your inputs and outputs. Right. And this is more or less what those look like. Once you have those defined, you can then create a prediction pipeline, or just a series of steps that includes the model and uses that model to make predictions. Again, in this case, we just say these are our input columns. These are our output columns. And then we tell this sort of ML.NET pipeline that we want to use that model to perform predictions, right? And once you put it all together, you essentially just go ahead and create an instance of your input. You run it through this engine to make predictions. In ONNX Runtime, you might see this as a session, right? Mauro is probably going to talk about this later. And then the resulting output, in this case, at least for this model, will be the predicted fare for your taxi, right? So in general, this is how you might go about, or one of the ways you can go about using ONNX models inside of your .NET applications that have been trained inside of Azure Machine Learning, specifically the AutoML components there. Now, we usually just do one doc here for our related bits, but I thought while we have Cassie on here, this is another related sort of doc or related bit here. Last week, Cassie put out this really cool article on how you can use stable diffusion with C# and the ONNX Runtime. So in their other related bit, you saw that the ONNX Runtime is a key component of using ONNX models inside of your applications, right? Specifically your .NET applications. And stable diffusion is this model where you basically provide a text input, and it just goes through a loop of trying to generate an image based on your input, right? In this case, you can see, make a picture of green tree and flowers in the red sky, and you can see that's pretty close to the prompt, right? So this is AI generated images. We'll share the link for this as well later on in the stream, but if you're interested, make sure to check out Cassie's post here and tutorial and get started generating AI images. So with that, let's go into the hallway track. Let me see. All right, Mara, the floor is yours. Would you like to, let me just switch screens here a bit here. Would you like to talk to us about Azure and ONNX?
Sure. So we started this on my little company we have just a little few problems with customers. Just to say, when we started to work, and we started just to have something like, okay, this is my previews, and my first beginning at work is like computer like this. This kind of computers is a platform completely closed. The first version was impossible also to save your work. The first version, the newest version, was possible to save on tape, but you can also every time use only on your platform. This is a very old computer, it's 45 years ago, I think. But what a lot of people think is that this kind of computer doesn't exist anymore. Yeah, the great Commodore. It was because now we are on the world of the cloud. All of us are connected. Our computer have some ways to share documents, to share connection. But if I told you that 10 years ago, all the data scientist laboratory worked like a Commodore 64, the same. All the software is custom software. Sometimes was written to specific hardware. It was difficult also to share some information between colleagues or people just inside the same organization. All the data are processing and are private data centers. My very first project was in 2006 about the first beginning of the IoT, and we have sensor handmade to catch the value of the minerals and the water in a vineyard with a radio signal collected by a tractor that passes by the vineyard all the day. And this data was just written on a portable hard disk, just shipped to the laboratory, to the data scientists to elaborate them. And they took 2 weeks, 3 weeks to have just a linear resolution. So something just today is possible to do with, I think, a mobile phone. And just to say, okay, you need to put more minerals or different kind of food to your vineyard. That today, remember 2006, today is prehistoric, archaic. We have a solar sensor. We get all the data. This data could be collected on the cloud. So we have the same project. And the same project is to say, okay, this is completely disconnected vineyard in the mouth. And then it's possible just to collect the data, send the data with a mobile connection, collect this data on the data lake in Azure, and automatically retrain all our models and the inference and just they create the alerts from the vineyard to be sent immediately to the new IoT like an automatic tractor that move to channel or to give other elements to the vineyard. In less than 15 years, the changes was to handmade something, have a closed laboratory, have everything in real time. So the beginning of the cloud era was okay, yes, it's good, but we can also take all this data and move what is our platform to Azure. So the first step is just to replicate virtual machine, replicate SQL Server, and move on the cloud. On the last year, also this changed a lot. Now we have services created to use directly the cloud we love. But also, our customers are not in the single project at the beginning when everything was a greenfield. Also, our customers start to say, okay, but we have to work on premise because we are bank and we cannot move to the cloud. Oh, that's okay. Oh, we are using another cloud platform. Oh, what a pity, but it's your decision. And at the end, okay, but we are as just a little company, the possibility to say I cannot provide the services to this customer. Or we have to just learn another platform that is costly. So it's costly. And we start to see that also for our customer, for example, if they use C Sharp on .NET, was costly. Have inside their on-premises data center people that use Python, for example, or they have to structure a new unit to say I have to people that use Python to put on production my TensorFlow, my PyTorch model. And we are happy to use Azure. We want to continue to use Azure. And at the beginning that the software was custom, it was also the problem to convert the software. We have software on C Sharp, we have software in Java, and our customers say, oh no, we want to use something else. For example, the first project for the Vineyard was written in Clipper. I don't know if someone is just listening has, I don't know what Clipper is, for example. It's very, very old. Uh, the new era started with, okay, now we have TensorFlow, we have PyTorch, we have Caffe, we have Keras, and also the models become to be very costly because they are really heavy. So it's not possible, imagine today, to say, okay, I read a paper about GPT-3 or ChatGPT, this is written in, for example, TensorFlow, but my company is using PyTorch. Okay, I have to rewrite everything in PyTorch and start the training again. Or just to say, the first training of GPT-2, there is a paper that say that just a single run of one epoch it cost $30,000. Just imagine to say I want to retrain everything from scratch. It was crazy. So it's not possible. In this era arrived the ONNX, the Open Neural Network Exchange format. That you say, let's just imagine is the XML of the JSON for the neural network. Something to say, okay, but I written something in TensorFlow. I want to save it in a language in this model that is possible to be reloaded, for example, in PyTorch. That was the beginning of the ONNX format. Also, it was usable when I have to change, for example, TensorFlow 1 to TensorFlow 2. I did the same. And this is the start of the conversion. We have the ONNX. That was the beginning of the conversion tools to get something on ONNX and move to another side. The idea was on this picture. When we are talking about neural network, at the end, we are talking to something that the computer have no idea what are the labels. So the basket in these images, what is the input, the images of the animals, and what happens inside all the path that start from the composition of our images that are input in a matrix, the input of the our neural network, and all the steps to arrive to the basket. Just to see these baskets labels are written in Klingon. So also for us it's quite impossible. I think this is someone that's talking Klingon, just raise a hand. But just to say, for the machine is the same. I have no idea. It's just okay. You tell me that this image is a cat. I try to move just simple machine learning magic that is nothing, is all math. So it's value inside these layers with mathematical function. And these values, these mathematical functions, is possible to export in the ONNX. So just not function written from PyTorch or TensorFlow, but single numbers and coding, just to say, okay, this is this layer, this is the activator, this is the input, this is the output. So totally agnostic. Just to say the conversion tools, all the conversion tools are used from all these kind of companies, and there's a lot more. So it is possible just to build, to export, and also just the idea was, okay, but imagine that I'm a customer. If I'm using TensorFlow, I wanted to just give an outsourcing. my code and want to use another company, this company internally know PyTorch, that's okay. I can save, they can reload the model. But what happens if my idea is that the data science unit do all the job of training? And as customers, I just want to run this model, just to do the inference of the model. I don't need to know that this was created on TensorFlow and Python because just I know this exists the ONNX possibilities. But also I don't want to reload everything, all the library, all the framework, because I just need to do the inference. And also, on my company, no one know about Python. I'm using C#. So if you know that we have the ONNX say, okay, you can export and run in something else. But if I can export, the only way that the data science have to put a little pay attention is the offset versions. So if I want to run something, it's just a version of the framework. It's okay. If we can imagine, this is this version. It's just to be sure that when I go to use the ONNX, I have, if I'm not using the from on the shelf TensorFlow PyTorch, if I've written something custom on my code, that I'm using an offset, so a function that is supported by the export in ONNX. This is the only little thing that we have to say. Just to not arrive at the end of the project and say, oh no, it's not exportable because I use something. Just to have at the beginning, one POC, little, is supportable to export. Yes, I can use something else. Okay. Just to not arrive at the end and to say, okay, it's not possible to be exported because. The other was, okay, I don't have to load. I can use my preferred framework. I target the testing. And also, because I've just to load to inference, but just as Luis showed us with Netron, that we'll see later, it's also to see visually the composition of this neural network was born, was created. So the main idea is, okay, I see my neural network. I was able to export my neural network in ONNX, and just I want to run it. And when the ONNX runtime arrived. The ONNX runtime is one of the runtime that was born on Microsoft. Now it's open source, so you find it on GitHub. And just you can say, okay, the data science part create for me the model. They say that this is perfect. It was exported in ONNX. And now I want to use my preferred language and my preferred architecture. The idea is, okay, on onnxruntime.ai, I'm here to the inference. Say, okay, I just run everything on my Mac. I select the Mac. Few options was automatically raised away because, okay, it's not supported on the Mac platform. Oh, that's okay. I'm using C#. I can use the C# in an Intel or the new Silicon chip. Okay, you are on an Intel Mac. You can decide to use the default CPU or do use the library optimized the core ML via. I follow the instruction and just install the ONNX runtime. Same things. I use Windows. I want to run the C#. I have an Intel. And I want to use something else, the default CPU, the NVIDIA, the Tensor T for NVIDIA. I want to use the OpenVINO optimization by Intel. So this is the main idea.
Hey, Mauro, can I ask a quick question?
Sure.
There's actually a good question in the chat about the offset, and it's asking, how does the offset get agreed on and who is influencing that?
Oh, generally, the offset is only the compatibility with very specific mathematical function. So if we are using, for example, chars, everything is supported. If we're using PyTorch, 96% of everything is just supported. If we start, for example, I don't want to use the default activator. I want to write me because, for example, I'm a researcher. So just I'm writing something for you. I just use different math just to be sure that this math is compatible.
Yep.
Is the only way to check.
And there's actually been a recent update to the ONNX docs that allows you to get a lot better kind of visibility to what ops are supported in what ops set. And
Yeah.
so I think that's what you
Also,
have up here as well. And then if you
I
try to
just
convert it with an offset that doesn't have it supported for your model, it'll tell you that it's not supported when you try to convert it, and it'll tell you which offset isn't supported. So you always want to try to use the most recent one that supports all the ops in the model.
yeah, I used a custom offset. I think only one time in 5 years of alpha with ONNX Runtime because it's just something really specific. On the other set, just if you want to update or to upgrade, if something this is, for example, a breaking change, like everything else framework, I think, but generally it's always better just to update because sometimes the more update is the best because sometimes just you see this is the 14. There's a lot of the explanation of the math inside the optimization. If we go to this version, sometimes this is quite the same of just change the implementation. The implementation so is not the conversion of the math, but something supported directed by the hardware of the driver. So you don't need to do a lot. Just start, okay, I think I used the last one. I created the first neural network, the summary, just export. If something's not supported, just also you receive, generally you receive an alert, and the alert could be also, oh, if you upgraded, just have a look, just that in the new version there is a breaking changes of. Just when you use also NumPy or other library, you load an old NumPy library and you receive a warning, for example, that said, okay, just remember that this breaking changes is changed. It depends on the tool, but sometimes is always it's quite easy, and you never need to go to see this part if you're using the standard framework. So don't worry about it.
We have another great question. I'll pop up on the screen here from the chat. This one comes from our friend Jose. And the question is, when using Windows subsystem for Linux 2, should we select Linux? What are your thoughts?
Yeah, absolutely. You can absolutely select Linux, and also if you use the next version that support directly, for example, the connection with the GPU, you can also use your GPU. So you can select Linux, and for example, say that you want to use the CUDA version from NVIDIA. So use the last one. Use also the Docker NVIDIA. You can also use directly the hardware acceleration of your GPU. Okay.
Thank you.
Welcome. So we also see that we have a lot of hardware that is coming to the ONNX Runtime, because the ONNX Runtime is just an optimization library, so you can just use to optimize your model. And or it's also possible to say, okay, I want to use the ONNX Runtime, but I want the optimization by, for example, the Intel OpenVINO. So if you change something on your software, you have to write code to call the OpenVINO library. If you just decide I want to move to another hardware, you have to write this. With ONNX Runtime, you can say, okay, I want to use the optimization by the ONNX Runtime, or the ONNX Runtime, I don't want to use it, my data scientists do nothing else, but I want to use, for example, the OpenVINO. Oh, that's the same. You can use the library of ONNX Runtime, It is the ONNX Runtime as provider will call for you OpenVINO. So just like a library is a wrapper for all the other hardware and software optimization that just implement the interface that the ONNX Runtime exposed to the ONNX Runtime library at the end. So also you can use ONNX Runtime always. And just if you have to do some specifics or you don't know in advance what is your hardware, you can continue to use without rewriting nothing at the end. This is just the optimization is for you from scratch. This is an example, for example. So sorry. And this is the training also you can see in the last one, the possibility also to optimize the training. What it means that normally we have a data scientist that complete the optimization, complete everything, and they say for us the ONNX model. And they say, okay, you can use the ONNX runtime just to do the inference. They run at the end. But also, if you know that you want to use ONNX runtime, that your data scientists are using PyTorch, you want to run this on CUDA from the NVIDIA optimization, why you to have to start from scratch all the training and optimize at the end? You can also apply a lot of optimization during the training. Also because you save time, and obviously, if we are running on the cloud, we are saving money. So we can use it for both, just to start the training, and at the end, just to run when we want. So now I think it's better to go to see directly the code and see how easy it is to use it. If you have any question.
Yeah, quick question here, Mauro. So it seems like for some cases you could also use it to optimize your training, but in terms of the hardware that this will run on, right? So for training, it's CUDA. So does that mean that, let's say that I use, ONNX Runtime to optimize training for the CUDA sort of hardware, right, and accelerate for that? Does it mean that I also have to use CUDA in inferencing, or can I choose something else once my model's ready for inferencing?
Yeah, at the end, if you are able, your optimization is possible just to export in ONNX, so you can use what you want.
Okay.
It's
so
not a problem.
Okay, so training I could optimize for a certain hardware, and then for inferencing I can choose another hardware, and it will optimize accordingly for that. Okay, perfect.
Absolutely, this is the great advantages. You don't have to choose at the beginning that was the old way. So there was also a problem for our customer because I want to use this kind of server, I want to use this kind of hardware like IoT devices. Okay. But I also have to train on the IoT devices. It was not possible, or terrible. Or just we have to use just the ARM CPU. Moving on. In this way, no problem. You can just train on CUDA. You can train on ROC from AMD, and just use what you want.
Great.
Okay. So when I start on my great Azure, I said, okay, we are using Azure, and our customer want to run on mobile phone. I say, okay, not a problem for us. We can move here. So we can create our new Azure Machine Learning project. I just select one from the West Europe. It's just the creation is quite simple, just a name and a position. We have our creation, just the subscription, the name. The other is just the container on my project. The magic stuff happen here on the Launch Studio. Okay, we launch Studio. And we are our machine learning platform. First thing to do is to create the hardware. So I want to run it in some hardware on Azure. The creation is not so complicated. It's like every other virtual machine on Azure. So I can see the possible virtual machines to create. I can select the CPU or the GPU. So, like virtual machines, I can do a lot of things to create my hardware. In this case, I create an hardware. I just select the application that I run inside. So this is a really standard DS11, so absolutely standard machine from Azure. I'll say, okay, now what I want to do. Next possible just to design my neural network. We can use the automated machine learning. Or just if we have something from very old school, or we have something that we have to create from scratch, we have the notebook. Later. Okay, and now we have my notebook. Okay, just to say a super easy example that everyone can follow. Our not very complicated problem is just our Vineyard decide also to see the type of kind of flower that they have in the field. And they can provide us the length and the width of the sepal, and the length and the width of the petal. And also we have three kinds of possibilities. Okay, no problem. Give us your data, or just put inside the data lake immediately if you have something that is, for example, taking picture of your flower. So we can go to see how this is possible. Okay, inside of to connect the data lake, in this case, I just uploaded the Excel file. Okay, this is my Excel file. I want to start to create my neural network. I select to create an environment. This is the Python standard that we found at the end of the installation of your virtual machine. And just decide, okay, my company generally use TensorFlow. Okay, I install TensorFlow. They finish to say, okay, TensorFlow ended. Okay, TensorFlow is okay. All the version that we have installed, and you start. Okay, now we're ready. I want to use Pandas, NumPy, the operating system, the matplotlib and sklearn to pre-process, that we see all the process, don't worry. Of TensorFlow, I want to use the keras, and my model will be a sequential model. Very, very easy project. Just I know that at the end of the process, my customer want to use this model in their data center. So then don't worry for you, I provide you the ONNX format of this model, and I install the tool to transform the TensorFlow to ONNX. If, for example, you use the latest version of PyTorch, you don't need converter because it's just inside the PyTorch. In the PyTorch, you have the model saved on ONNX. So I read my file. Okay, the file, we have the sepal length, sepal width, petal length, petal width, and we have the species. We have the float. At the end, there is the string of the type of my flower. So just remember the image of the neural network. I have to separate the data, the animal picture, from the basket. And in this case, my basket is the species. So on the X, the value, on the Y, there is my label. Also, I cannot provide something that is a string to a machine. There is only 0 and 1, this is a matrix. So I decided to encode. So the first is the category 0, the second is the 1, the third is category 2. And also I decided to split my dataset. 70% will be used to train my neural network. The 30% will be used to test at the end what happens. Okay, there is the shape. And now the super easy neural network. So I want a neural network that is just sequential. start to end. I have just one array, and as we see, we have all the 4 features, so the sepal and the length, the petal, and sepal. And I start with 1000 neuron with the activator the value. So my first input is 1000, the second one 500, 300. I drop out, so randomically remove 20% to see that it's not just learning too much. And just at the end, tell me, okay, you have to decide the ball on my neural network. We have the major probabilities to decide a basket. I choose an optimizer. I see that there are more than one categories. We have 3 categories in this case, and they want to be optimized for accuracy. My model is compiled, and to say, okay, start to run. Every POC is studying, the validation loss is reducing, the accuracy is just improving, reducing just a bit. At the end, okay, I'm ready. This is the summary of what I trained. Just imagine the trainable is 600,000 parameters. Just a stupid evaluation, just to say, oh, okay, can evaluate this. Okay, 93% of accuracy. We have the plot, what the loss and the accuracy change is quite constant from the training data set to the test, so it's a good model. Just the answer on this way, so category is the second one, the first one, the second one. And let's imagine that the data science unit to say, okay, for us is completed. We do all the optimization. We decided to do everything. Now the model is perfect. Okay, now we have to provide the model to the customer, and that's okay. Import TensorFlow to ONNX, and just have to specify the kind of input. So on TensorFlow, because I use TensorFlow, I created the TensorFlow specification, so the kind of definition of my matrix of input. The output, it doesn't matter. We have 4 features. The kind I can use the float 32, and with a lot of imagination, I call the input. I just say, okay, this is just the output name, and I call the tool TensorFlow to ONNX, convert from Keras, my model. The input specification is in this way. I select the offset, the 15. I want to use this output. Okay, this is completed. I go here, I have the new sequential tree. This is my new model. And if you want to see this model is done in this way. We have an interchange version with the tool test created, the product version, and an explanation of the node. Obviously, it's not so good to see this in this way, also because when the start the matrix is impossible. But as Luis showed us, we can see this is a simple sequential in this way. You remember we have 1000, the ReLU, the 500, the ReLU, the 300. The 300 here with the dropout explained all inside of our matrix, and then sequential. If you also see that you don't need to provide a lot of documentation to your customer, because sometimes you have to provide all the Python environment, the version of everything. In this case, you have easy to say, this is the input. This is a float 32. It is just for feature. This is the name at the end, because I not named. You can just rename the input. And the output is the float 32, and you have to receive 3 values. This is the categories that we have, just the 3 categories. Okay, but because I want to work properly with my customer, I just don't provide immediately to my customer the ONNX. I want to text it. I have to test it. If we want to test, okay, I can just test it immediately, just here in Ubuntu on Python. So I get my notebook and say, oh, this is my notebook. I want to install the ONNX Runtime only, so who cares what's started on TensorFlow? I just import the ONNX Runtime in the NumPy. I select a provider, so I want to use the default CPU provider, and I load, so we can just load R, say ONNX Runtime, load for inference this model, and just get the providers that are available from the get providers. Okay, don't worry. What is the input? The input is called input, is a TensorFlow, and here I have 4 features. It's possible to be written in a smart way, but it's just really easy to understand all the steps. Okay, I create an input feeds. The input feeds is input.name, so it's called input. I create an array with 4 values on float 32 array. That's okay, this is my value. And just I call the run. This is none that we declared. It tells the input feeds. Okay, this way I have 3 values, but I just call what is the index with the max value. The category is the category 0. If I change something, because I have to see another of the flower that arrived to the field, okay, they changed. They decide that in this case, on Python, we can just put a run, of which we can create the endpoint to expose this on ONNX directly on Azure. But we see that our customers say, I don't want to use Azure, I cannot use Azure, I want to run, for example, an IoT device. And this IoT device on my smartphone, we want to use something else. Okay, no problem. Because I am a .NET developer, and I hope I want to use .NET to also to run on the mobile, use the MIUO Dexamine. I create, in this case, to have an example, a console application on .NET Core 6. Okay, this is my project. In this project, I installed the Microsoft.ml.ONNX Runtime. That is absolutely the same that we have suggested here. If I select that I use on Mac, on C#, on default CPU, go to the default and say, and you have the same. You can install the little library and then you get MLX or X runtime. So follow the instruction, install the NuGet, everything is installed for you. And what happens here? I just define where is my ONNX. I read the inference session. I create a denser tensor, so something that is possible, so the metrics on machine learning way. I put some values. Is the same from the Python version. I convert my tensor to ONNX value input. That's the name, input value, the input tensor is the tensor. And I call run. I call the inference. I transform the tensor to the array and ask again to have the argmax. Here we are. It is loaded. We have the output. The output are absolutely the same array with the values. And at the end, This is the result, and the result is 0. If we change the input, I don't remember the value, but it's quite the same. We run again, the Python works. So what happens if I don't change nothing? If the exporting is one-to-one without optimization, it works at the same. It's Python, it's C#, because it's the same model. It's absolutely the same model.
I think it's cool to see how similar the two APIs are to, like, doing your inferencing in Python and then jumping over to C# and seeing that the process, and that's similar with whatever language you decide to do your inferencing in, the process is always kind of the same.
Yeah, it's always the same. You just load the model.
Mm-hmm.
I think that's a nice segue into our next question from our friend Jose again. And he asks, could you please define what we mean by inferencing in this particular context?
Yeah, inferencing, you have to switch the artificial intelligence just in two parts. The first is the training. So when the neural network is learning where there is the correct basket to move the value of everything just to arrive to the correct basket. The inference is just the question to say, this is my value. You have trained. Tell me what is the final result. So when I created the inference session and just call to the run, it means this is the new value. Just to run my neural network and just go to arrive the ball inside the correct basket for you. So it's just the same. They make a question to ChatGPT. The run is, this is my test. This is your output. In this case, the running is just your question.
So it's inferring an answer based on what it's learned from the data when we trained the model. So it's inferencing, it's inferring.
Yeah.
And there's another question asking if the inference session needs to be disposed.
No. If you had the session at the end, generally it's exposed by an API, is opened at the beginning and running for all the time. But at the end, if something's close, you don't need.
I see another question here as well.
Yeah.
Thanks for all the questions, folks. Pop this one up on the screen. Any custom tensor models can convert into ONNX?
If they are supported in the offset. If you are supported on the offset, yes. You also can write the conversion custom. Mm-hmm. For example, if something in the offset is not directly used, but there are the mathematical elements, and you can write the function you need. It's just a little complicated, but it's possible. Just use the primitive of the math. So in general, everything is possible. Oh, sorry, yeah. Cassie.
Oh, no, I was just going to say more and more getting supported with each new version too. So it's getting better and better from that perspective of supporting model architectures.
Oh, also they can open an issue on GitHub, but also I need it.
Yep. Another thing I was thinking about with the ONNX format that I think is interesting and something that we've been working on too is serializing your pre and post processing for your model into the model itself. So the pre and post processing, where you're actually taking your image and turning it into a tensor and then sending that into your model. Right now, you have to do that in each individual language, or you did. Now you're starting to be able to actually put that pre and post processing into the ONNX model itself. So it makes your running on each platform a lot more simple. And that was something that was recently released, and we're starting to add more and more use cases. So when you're thinking of the ONNX format, I'm starting to equate it to almost like a DLL. Like you're grabbing it, it has all of this stuff pre-processed, and you're just running it in your code and getting the result or the inferenced result, and then making decisions based on that in your code.
Yeah, totally. It's a great new feature. And here there is my Visual Studio running on Parallax, so on Windows. But also it works the same. Just time to load and work. The code is absolutely the same. So I copied the Visual Studio code from Mac. I moved to Windows. I just also obviously changed the path, but it works absolutely on the same way. When they start to, we can continue also to see that the new provider that arrived to the ONNX Runtime, for example, if my customer want to use the mobile phone, it's just possible to use specific version to the Android, if you have the Qualcomm Snapdragon CPU, and the Core ML that we see. So there is no problem. Also, the news is that we can use OpenVINO, also that is written by Intel, to the ARM CPU. So also it's possible to debugging it. Just imagine the power of run this where do you like, because at the end it's just time to see if it is supported, and if it is supported also it is possible just to run. Okay, and you see the code is absolutely the same. I just installed the Microsoft ML ONNX Runtime.
There's a couple more questions here. One says, can the model be run on a cluster?
Absolutely. Absolutely, it's possible to run on a cluster. For example, we run on cluster just a moment using OpenVINO, the Xeon cluster. So for example, we have Xeon cluster. We use ONNX Runtime. So we continue to use ONNX Runtime to change our code. And this configured to use the OpenVINO runtime.
So, quick question here, Mauro. Every time that I want to inference, do I have to convert the model each time, or how does that work?
No, you convert the model at the end of the training. So we data scientists say it's finished, it's completed. For the for the inference, you have always the same model. You can just load the same model. So if they change the model, you are obviously to export again, just to have the string outside on a configuration file. If they don't change the input, they don't change the output, you don't have to touch nothing else about your code to have the inference. Also, it's possible just when in this case, is using the default, but also it's possible to change the providers if the providers are supported, just for the configuration file. So this is the beauty of the ONNX Runtime. So I change the model, I want to change the provider, I install correctly the ONNX Runtime in the platform, and that's it. Nothing to be changed.
I see. So because it's a one-time cost, it sounds like obviously if you change your model, you would have to export again, but it sounds like it's a one-time cost to convert the model. We have a question. Whoops, lost the question for a second there. We have a question here from Sharafuddin who asks, do you face performance issues while converting multiple tensor models?
No. No. It's possible just if you want to use the ONNX Runtime, for example, optimization. If you wanted to quantize the model, you compress the model, but not just in performance. You can lose, for example, in accuracy, because you want to compress a lot your model. So it's not a problem of the ONNX or the ONNX Runtime, but it's our choice to modify the model to be to use less RAM, for example, or to be optimized to use some hardware. But it's not a problem for the ONNX or the ONNX Runtime.
Right. So when you're choosing your hardware and when you're making your model and thinking about where you need it to run, you have to take in consideration, the hardware that you need in order to support your model. But that's not something that the ONNX Runtime controls. That's like decisions you make architecturally when you're thinking about operationalizing your model.
Yeah. Just imagine if I wanted to export something is a stable diffusion on ONNX, I can. But if I want to run it on a mobile phone, I have just to trick the model, because it's the hardware or the power of the hardware that is not suitable for the model. But
And that's same with like when you're choosing the execution provider, you choose the execution provider for the hardware you want to run on. You can have a list too. You can have multiple, and you can even decide logically check if something's available and use the execution providers that's available on the hardware if you're running on device. So there's a lot of configurability within that in order to kind of like meet your goals.
Yeah, this is the great value, because you don't have to use the libraries for every hardware or every software, but just you can use ONNX Runtime and just install what you need on the machine and your code just to use always this kind of ONNX Runtime code. So a great wrapper for every kind of platform. That just for us means if our customer want to use cloud, okay, you can have GPU, CPU. They want to use an Android, okay, you have the Android or you have a Snapdragon CPU. They want to use the iOS, okay, this is the Core ML. But we'll change, the only things change is at the beginning just to say the ONNX Runtime provider and the installation of the machine. Obviously, if you want to optimize a lot more, you can also continue to use the ONNX Runtime, or you are just to write something just like the provider is in this way. The option of the ONNX Runtime is this, but it's your own. It's you to decide to change the one-to-one conversion of the ONNX.
Yeah, so there's also the performance optimizations that you can do, like you said, with ONNX Runtime to just get faster inferencing in order to meet those things as well. Another new thing we just released too is around hybrid inferencing that allows you to, like with one line of code, change from running on device to in the cloud. So you could have a more simple model running locally, and then you could have a more complex model running on Azure ML. And just by changing a bool to true, you can offload it to the cloud. So that's a new thing that we just released as well to kind of support different hardware needs and different model deployment architectures.
Yeah, because as you see, there is a lot of tools. For example, it's all the tools that is possible just to convert. There is a lot, I think, all them. It's very long possibilities just to convert. The cloud service that automatically can use or can just save on ONNX. And all the possibility just to inference, and that's ONNX Runtime just work also as a wrapper, for example, for CUDA, for TensorRT, for TensorFlow, for Windows. And the possibility to optimize. Oh, yeah.
Sorry to cut you off there. We're running a bit low on time, but I thought maybe we could take one last question here before we wrap up the show. So in this case, we saw one ONNX model and running one ONNX model, but Sharafudin asked, can you combine multiple models into a single sort of ONNX file here?
Just as I said by Cassie, just it's possible just to do a lot of things now.
I've never tried to. I don't think you could put two models in one, but you can string inferencing and share sessions and things like that to run multiple models. Like multi-model solutions are really popular now. And I know, and like I was saying, you can add in the pre and post processing, but I think you'd still have to have separate models and separate inference sessions, because also a lot of times when you have multi-models, you need the output of one model to feed into the input of the next model. It's not usually like if you wanted it to all run as one model, it would probably just be one model with one input and one output. But generally, multi-models have different tasks. Like each model, think of it as like a function that's solving a specific task. And so this model is going to solve that task, which is going to have an output, which is going to go to the next model, which solves the next task. So that's definitely a common scenario, but they would still be serialized as separate models unless it was all part of the same task, and then it would be one model.
Yeah. Or the one is if you want to create an ensemble, automatically just merge your model together, but it's quite unusual, but it's possible.
All right. As Luis alluded to, we are at time for today's show, unfortunately. But I would like to thank our viewers for tuning in yet again today. Thank you, Mauro, for your time.
Thank you too for having me.
Super appreciative of that. As a reminder to our viewers, you can check out other .NET Live streams like this one that you saw today and recordings of those shows over at dot.net/live. If you tune in next week, this will be next Monday, we'll be joined by guest Johnny Hubergs, who will join the show, and he'll talk about his experience in building an educational game using tech like C#, Unity, Orleans, and Azure Container Apps. We hope to see everyone next week. Thanks again.